In this session, we will create a Violin chart as an interactive plot. We will use Dash library for this purpose. Dash is built on top of Plotly. Dash is a productive Python framework for building web analytical applications. It is developed by Plotly and is particularly tailored towards creating data visualization interfaces. Dash enables developers to build interactive web-based dashboards using pure Python without the need for HTML, CSS, or JavaScript coding, though these can be incorporated for more advanced customizations. A Violin plot is a mix of a box plot and a kernel density plot. The Violin plot has a shape similar to that of a traditional box plot. However, instead of a box, the Violin plot uses a violin shape to represent the entire distribution of the data. The violin shape is created by plotting a kernel density estimate or KDE of the data, which shows the probability density of the data at different points. Violin plots are particularly useful when the data set has a lot of outliers or when the distribution is highly skewed. They allow you to visualize the entire distribution of the data, including the tails, which might not be visible in a box plot. They also allow you to compare the distributions of multiple groups of data by plotting multiple Violin plots on the same graph. IQR that you see on your screen corresponds to interquartile range, which is the difference between 75th percentile or Q3 and 25th percentile or Q1. IQR is used in box plot to determine the upper and lower bounds for identifying outliers. The 50th percentile is nothing but Q2 or median. You may have a fundamental question. When there is a box plot, why do I need a Violin chart? The key advantage of a Violin plot over a box plot is its ability to show the entire distribution of the data as well. While a box plot summarizes the data with median, quartile, and outliers, a Violin plot combines a box plot with a kernel density estimation on each side. This means it not only shows the summary statistics, but also the probability density of the data at different values. This can reveal the presence of multiple peaks in the data, which will not be visible in a box plot. A Violin plot with its KDE can illustrate whether the distribution is symmetrical or skewed, or it has a uniform distribution, or it is bimodal. All these can be critical for further analysis. The additional information provided by KDE can make these plots more informative, albeit at the cost of being slightly more complex to interpret for those unfamiliar with them. Let us start with the pip install process. We will import the necessary libraries. DCC is the core components module of Dash, which contains components like graphs and dropdowns. HTML is the Dash HTML components module, which allows you to use HTML tags as Python objects. Plotly.express is a plotting library that simplifies creating complex visualizations with concise syntax. The dataset is loaded into a pandas data frame DF from a CSV file, which contains insurance data, including insurance charges, smoker status, age, and gender. px.violin creates a Violin plot using the Plotly Express library. In this plot, Y represents the insurance charges, X is the smoker status, color differentiates by gender, box displays a box plot inside the Violin, and points displays all individual observations. We now initialize a new Dash application. App.layout defines the HTML layout of the Dash app, which in this case contains a single graph component from DCC displaying the Violin plot. This block checks if the script is the main execution and not imported as a module. If it is, it runs the Dash server, which starts a local web server to host the Dash app. The debug equals true argument allows the server to automatically refresh for code changes and provides an in-browser debugger. Now let us go through the violin chart. The width of the violin shape at different points on the y-axis indicates the density of data points at that charge amount. A wider section means more data points are concentrated around that value. For smokers, the distribution of charges is wider in the higher values, indicating that smokers are associated with higher insurance charges. For non-smokers, the violins are narrower and more concentrated at the lower end of charges, suggesting that non-smokers tend to have lower insurance charges. Within smokers, male charges are slightly higher than female charges, as seen by the positioning of the red violin slightly higher than the blue one. Among non-smokers, the difference between gender is less pronounced. The violin plot is available as an interactive one. We can zoom in or zoom out, and we can also select a particular area for further analysis. There is also option for auto scale, and this will reset the axis.